You'll hear two university students planning a computer programming lesson. First, you have some time to look at questions 1 to 4. Now listen carefully and answer questions 1 to 4.
Hi, Hardeep. Is now a good time for us to plan that computer programming lesson we've been assigned?
Hey, Don. I was just thinking about that, actually. Yes, let's get it out of the way now, shall we? I've got the instructions here. So, it says, design a 45-minute lesson for a class of 16 teenagers where they learn how to write a simple computer program in BASIC.
Now, I know, of course, that BASIC is the computer language people used to use back in the 1980s when they wrote programs on microcomputers, but I'm not sure I feel very comfortable teaching anyone about it.
Well, I did a bit of research yesterday and found out quite a few things, so I think we'll be okay.
Great. So, what do you have in mind?
Well, I think we should presume that none of the kids will know anything about BASIC. So why don't we start with a short multiple-choice quiz? It could focus on things like what BASIC is, what the letters stand for, when people used it, things like that.
That sounds good. I guess it shouldn't take long. Just the first 5 minutes of the lesson, something like that. I don't think we should make the students do it on their own, though. That'd make it too much like a test. Shall we let them do it in twos so they can discuss their choices?
Yes, good idea. Then we'll go through the answers with them as a whole group.
Good. What next?
Well, I've had an idea for the program they could write. I'll tell you about that in a minute. I think the key thing is, though, that before they actually sit at their computers, and I think we should presume that they're doing this lesson in a computer room, they make a flow chart of what they want the program to do. That's usually the best way to start writing a program.
This flow chart will show all the different stages of the computer program, right?
Exactly. It's probably best if the teacher stands at the board and everyone works on that together.
Yes, otherwise they'll all come up with different flow charts and it'll get confusing.
Precisely. I imagine making the flow chart will take about 15 to 20 minutes.
Then they use that to write their computer program.
Well, actually, I think there's a stage before that. You see, the flow chart will be in English. They're going to need to be taught a few basic commands so they can write their computer program.
Now I'm getting out of my depth. What kind of thing would that be?
Well, for example, when you want text to appear on the screen, the command is print in capital letters, followed by the text you want to appear in double inverted commas.
Oh yes, I think I've seen that before.
Right. So they'll need to be taught 5 or 6 commands before they use them to write their program.
Okay, so how shall we do that? With the teacher talking to the whole class again?
Well, we could, but it might be more fun to make it more like a competition, where there are a few teams competing against each other. Each team has maybe 4 or 5 people in it, and they have to do some kind of matching task. You know, they match the command print with to make text appear on the screen, something like that.
That sounds good. Teenagers love competing with each other.
Exactly. And then, for the final part of the lesson, they use their flowchart and the commands they've learned to produce the program. Let's presume, shall we, that there are 8 computers in the room, so that's 2 students for each computer.
That sounds reasonable. So, tell me more about your idea for the computer program they're going to write.
Before you hear the rest of the conversation, you have some time to look at questions 5 to 10. Now listen and answer questions 5 to 10.
Okay, so it's a very simple program. I've actually written it down here so we can go through it together.
Okay, so the first line says 10 CLS. What on earth does that mean?
Well, every line of a basic computer program starts with a number. They usually go up in tens, so the first line is 10, the second 20, and so on. And CLS is the command we use in BASIC to clear the screen.
Oh, I see. So that's just telling the computer to start with a blank screen.
Exactly. Then we move on to the next line. So this one says 20, print, guess a number between 1 and 10.
Right, I see. That appears on the screen. It's not that difficult, is it, when you get the hang of it? Let's see if I can work out the next one. 30, input I. Oh, not sure about that.
Well, all that's saying is that the person playing types in a number. Input is the basic command for type in, and I just means any number you like.
Oh, okay.
Then what happens next depends on what the number is. So we've got 40 if I is less than 1, or if I is greater than 10. Then print. Bad choice.
Right, so if they type, say, 0 or 11, that appears on the screen.
Exactly. And then this next line takes them back to where it asks them to type in a number between 1 and 10.
That's line 50. I see. And line 60 says, if I equals 6, then print. Correct. Ah, okay. So if they've typed 6, they've got it right.
And if they haven't typed 6, which is the next line, then try again comes up on the screen, and that takes them back to where they choose another number.
It's clever. Well done.
That is the end of part 1.
You now have half a minute to check your answers.
Now turns to part 2.
Part 2.
You will hear 2 first-year engineering students discussing their project on devices which have been specially designed for use in developing countries.
First, look at questions 11 to 14. Listen carefully and decide which 4 planned developments are mentioned.
Hi, Aileen. Thanks for coming.
No problem. We've got our presentation coming up on Tuesday, so we need to get everything prepared now.
Yeah, so we're agreed that we're going to concentrate on these 2 devices which have particularly helped people in developing countries.
Yes, and we'll present the information in the form of a table, so it'll be really clear for non-specialists. We'll have 3 columns, using the headings we discussed in the last seminar.
Okay, I've got those here. I'll make notes. So let's start with the clockwork radio and how it works. We'll obviously say how it's powered, i.e. that it's wound up.
Yeah, and we'll also need to explain how the energy is stored.
Okay, in a spring.
Fine, keep it simple. But we also need to say that the thing which makes the mechanism so special is the inclusion of a gearbox, which makes it possible to release energy extremely slowly. And that means that it can operate for a long time with minimal effort.
OK. Now, the next section is what are its benefits? I suppose we just need to emphasise that it costs a lot less than radios which use batteries. And if we want to, we can explain that these can cost as much as a week's wages in some parts of the world.
Absolutely. And related to that, of course, is the fact that people don't have to depend on buying anything in a store, which in remote rural areas is really important.
And then in the developments column, I think the most important thing we need to say is that the combination of the wind-up mechanism with a solar cell means that during the day it runs on the sun's energy, and you only have to wind it up when it's dark, which makes it a much more attractive option.
And that's probably that for the radio.
Yep.
Before the broadcast continues, look at questions 15 to 20. You will now listen to the second part of the talk.
So we'll then move on to the solar box cooker.
And again, let's keep the description of the mechanism very simple. We need to say that it uses sunlight rather than conventional fuels to cook food.
But we also need to explain two elements of why it's so efficient.
Yeah. The fact that sun's rays enter through a plastic cover.
Better call it a lid. I thought it was made of glass.
Not according to my research.
OK.
And then we just say that light is transformed into heat and...
Because it has a longer wavelength means that it gets trapped.
And so it cooks the food.
Good. Right. And then where do we begin on the advantages? There's so many.
I suppose we have to begin with the fact that you no longer need to cut down trees, which brings a whole raft of other benefits in its turn.
Sure. And related to that, I think we need to say that because dung is no longer needed as a fuel for cooking, it can be used as a fertiliser.
Which leads to better harvests.
And then there's the fact that there is absolutely no smoke. I was reading somewhere that there's a huge incidence of lung complaints, especially among women and children who have to breathe in smoke from conventional cookers.
So that's another plus point.
Yep. And then we need to say something about the way cookboxes have been improved. I think we can emphasise the fact that a reflector is often added at an angle to the lid to maximise the amount of light entering.
Yes, good point. And also, I read about the fact that the floor or base of the box is raised, which improves heat retention.
Oh, and I think we should mention the fact that many of the new boxes have a sloping or inclined lid, which increases the surface area to capture the sun's rays.
Yes, that's a good point to finish on, I think.
So, I'll write up that table on an OHT if you like, and we're all set for our presentation.
Yes, great. If there's anything else that you think we should discuss...
That is the end of part 2.
You now have half a minute to check your answers.
Now turns to part 3.
Part 3.
You will hear a discussion between 3 students, David, Joseph, and Carrie. In the first part of the discussion, they will be talking about lounges in different school buildings on campus. First look at questions 21 to 24. Now listen to the first part of the discussion and answer questions 21 to 24.
Hey, Joseph. Long time no see. How's it going?
Oh, hey, David. It's going fine. I'm a little overwhelmed with all these new courses, but I'm hanging in there. Have you met my girlfriend, Carrie?
No. Hi, Carrie.
Hi, David. Joseph told me about you. You two had quite the time last semester in European history, I hear.
Yeah, we like to hang out after class. Now it's a little harder, though. Lounges aren't as good as they were back there in Wilson Hall.
Yeah, they had chairs, couches, and tables to put your stuff on. And that lounge was full. There must have been 25 seats in there.
Really? The lounge in Jones Hall, where I have my communications course, only has about 10 chairs. It's awful. We all just stand around or leave. I wish we could hang out more.
Well, Agriculture Hall is next door. Their lounge is on the first floor, and it has couches. I think there are about 6 of them, and they're comfortable and hardly used at all.
That's not a good idea. Thanks.
But don't go to lounge at Skidmore Hall. I don't even know why they call it a lounge. It's just 4 chairs in the corner of the main walkway.
In the second part of the discussion, David, Joseph, and Carrie continue talking about conducting a survey.
Before you hear the rest of the talk, you have some time to look at questions 25 to 30. Now listen and answer questions 25 to 30.
Guys, we should really do something about those lounges. I mean, couldn't we gather signatures and try to get the university to improve some of the facilities?
Yeah, that's a great idea. But we can't just say something random like, oh, you need to make the buildings nicer. We should come up with some kind of ranking system and have students rank buildings, how beautiful they are, how nice they are, etc.
Well, if we were ranking on a scale of 1 to 3, you all know that I would rank Skidmore Hall a 1. Like I just said, that place is awful. No facilities. The bathrooms are way down in the basement.
You're right. But they do have a nice balcony on the 3rd floor. That might increase its value.
But you shouldn't rank the architecture. You should rank how nice the building is for students to hang out in.
Oh, okay. Then I agree with you.
So should we do this? I think it's a great idea. But let's try it ourselves on a couple buildings so that we can work out any bugs in it. I think Wilson Hall is the best.
Sure, but we've already begun. We will give a building 1 point if it has poor facilities, not enough chairs and no vending machines, that kind of thing. And give a building 2 points if it is okay or acceptable. We can rank buildings that we really like as having 3 points. So like Joseph said, I think Wilson Hall is the best. It should have 3 points for sure. And Skidmore has a 1. Now what other buildings should we rank?
How about Merris Hall?
No, they're not done with that one yet. But it looks like that will be a good place to hang out. How about Agriculture Hall? You said something about that hall a bit earlier.
Oh yeah, they have that lounge with couches that no one uses. But that might indicate that people don't hang out there for other reasons.
They don't have any drink machines. That's why I never go there.
Oh, well, then I think it's an average building. Let's give it the middle ranking.
I agree. It could be improved slightly, but it's got a couple of nice features. I like that lounge in that 3rd floor, for example, but the stairs are too short. I always trip when I'm walking up them.
This ranking is getting complex. Okay, one building we haven't talked about is Canton Hall. What do you guys think of Canton?
Is that next to the law building?
Yep. It's got this excellent connecting corridor with chairs and desks to relax and work at. The cafeteria there is great too. I think that place is just as good as Wilson.
Well, I've only been there once, and didn't know that was what it was called. It was kind of confusing, and it's kind of far for me to go, but I liked it. So I'll give it the middle ranking. 2 points because it had nice facilities, but a poor and confusing layout.
Oh, Joseph, you like Canton Hall? I hate that place. It's so mechanical, cold and impersonal. The furniture is nice, sure, but it's the last place on campus I would go to. I give it a 1.
Interesting. Well, let's write this little survey up and start passing it around.
I don't have time to type it up. Can you?
Sure. I'll do it after my biology class. Should we meet up at Wilson tonight around 8?
Sure.
No problem. We'll see you then.
That is the end of part 3.
You now have half a minute to check your answers.
Now turns to part 4.
Part 4.
You are going to hear some facts and figures about Australia.
First, you have some time to look at questions 31 to 40. Now listen carefully and answer questions 31 to 40.
Now, I should tell you that the country of Australia is made up of 6 states and 2 territories. These are the Australian Capital Territory, New South Wales, the Northern Territory, Queensland, South Australia, Tasmania, Victoria, and Western Australia. The national capital is Canberra. Right, let's turn to the Australian economy. Australia has a prosperous Western-style capitalist economy. Australia is a major exporter of agricultural products, minerals, metals, and fossil fuels. Commodity prices have a big impact on the economy. Australia suffered from the low growth and high unemployment typical of the OECD countries in the early 1990s, but the economy has expanded at reasonably steady rates in recent years. In addition to high unemployment, short-term economic problems include how to balance output and inflation and how to stimulate exports. The economy is made up like this: agriculture, 3.1%, industry, 27.7%, services, 69.2%. The labor force has a similar pattern. The total labor force is 8.2 million. 34% work in finance and services, 23% work in public and community services, 20% work in the wholesale and retail trade, 17% work in manufacturing and industry, and 6% work in agriculture. What are the chief industries of Australia? They are mining, industrial, and transport equipment, food processing, chemicals, and steel. What are Australia's main agricultural products? They are wheat, barley, sugarcane, fruit, cattle, sheep, and poultry. And who do we sell our products to? At present, our chief export market is Japan, which takes 24% of our exports. After that, South Korea takes 8%, and New Zealand and the U.S. each take 7%. In years to come, however, we expect China to become a significant trade partner. China already supplies 5% of Australia's imports. This is the same amount as New Zealand. Meanwhile, we take 1/5, in fact 22% of our imports from the U.S., 17% from Japan, and 6% from the UK. So what sort of things does Australia import? Well, we import a lot of machinery and transport equipment, especially computers and office machines, also telecommunications equipment, and in addition we have to import oil and petroleum products. So let's move to the subject of communications in Australia. We have an estimated 8.7 million telephones and 9.2 million televisions. There are some 134 television broadcast stations and 325 radio stations. The related subject of transport is naturally very important in such a big country as Australia. Let's look at highways first. There are two kinds of highways, paved and unpaved. Paved highways are regular roads with a permanent surface. But actually, we have more unpaved highways, around 60%, than paved, when all the country roads are included. In addition, Australia has a railway network of over 38,000 kilometers. But you'll probably find it hard to believe how many airports we've got. 10? 20? 50? No, the total is 443. Of course, this includes many short runways on farms and in the outback. There are only 9 airports with runways of more than 3,000 meters.
That is the end of part 4.
You now have half a minute to check your answers.